Good morning all, myself Dr. Priya, working as Associate Professor in Department of Humanities and Sciences, MLR Institute of Technology, Hyderabad. So in today's session, we are going to discuss about solid oxide fuel cells. These are an example for various types of fuel cells we have. This is one of the examples in which we will make use of solid material as electrolyte. That's why it is an example for solid oxide fuel cell. In short form, we will call it as S4FC. So let us study its construction, working and applications part. So coming to the construction, so it will have two chambers. One is meant for anode, another one is meant for cathode chamber. So into the anode and cathode chambers, we are going to insert ceramic electrodes. Electrodes are made up of ceramic. And into the anode chamber, we are going to bubble hydrogen gas. And into the cathode chamber, oxygen gas, it is bubbled. And which is the most important component of any cell, that is electrolyte. So the speciality of this battery is, in every battery we are going to consider that electrolyte in a liquid form. So in this solid oxide fuel cell, we are going to consider a solid material of electrolyte. So it is a totally dry one. There is no question of liquids in this one, because we are going to make use of solid mixture of yttrium dioxide and zirconium dioxide. So this will play the role of electrolyte. So for maintaining a complete electrical contact or circuit, so that electrodes are also made up of ceramic material. So the solid mixture of yttrium dioxide and zirconium dioxide is nothing but ceramic material. So solid material, that is ceramic material, it is taken in the place of electrolyte. That is the speciality of this construction of solid oxide fuel cell. And as we are considered that ceramic material, its working temperature range will be enhanced, that is 700 to 1000 degrees centigrade. So this speciality of this fuel cell, it is, we will make use of solid material, that is ceramic material, in the place of electrolyte. And this can be applicable. That means we can consider any fuel cell like hydrogen oxygen fuel cell, methanol oxygen fuel cell, anything we can consider, and simply replace its electrolyte with this solid mixture of ceramic material, that is yttrium dioxide and zirconium dioxide. Then definitely it is converted to a type of solid oxide fuel cell. So in this case, I am going to make use of hydrogen oxygen fuel cell, in which its electrolyte I am going to replace with this yttrium dioxide and zirconium dioxide. So as I told you, coming to its construction part, so if you notice, it is having two chambers. One is acting like anode, another one is acting like cathode chamber, into the anode chamber I have bubbled hydrogen gas, and into the cathode chamber I have bubbled oxygen gas. So and then these two are separated by a electrolyte layer, that is nothing but made up of ceramic material, that is a mixture of yttrium dioxide and zirconium dioxide, right? So we know very well what will happen. Always at anode oxidation will take place, and always at cathode reduction will take place. And as a whole, if you notice, flow of electrons will take place from anode to cathode. That means flow of electrons is possible, then it is able to generate the current. So its output voltage will be 1.21 volts, just like the other fuel cells. So let us see the working part. So coming to the working part, cell reactions will include, at anode we have a bubbled hydrogen gas, right? So it is able to release electrons. By involving in oxidation. So it is able to release its corresponding H plus ions along with the electrons, right? So at cathode, oxygen gas, it is bubbled. So it has to involve in reduction. The electrons which were lost by the anode, that is hydrogen, were gained by the oxygen, thereby it is able to convert into O2. So if you notice, that is, it is reduction reaction. If you notice the net cell reaction, like terms, they get cancelled on both sides of the LHS and RHS sides of the anode and cathode reactions. So if you notice this one, H2 plus O2 gives rise to H2O. So finally we will get water as the product. So along with that, what I told you is 1.21 volts of electrical energy will be generated. So coming to the net cell reaction, we are getting water as the only byproduct. That's why it is having lot of applications in the space side or spacecraft side. What are the advantages of this SOFC, or we can say solid oxide fuel cell? So as it is an example for solid oxide, or we can call it as a ceramic material which is playing the role of electrolyte. So these become electrically active until they reach very high temperature. So that's why its working range it is very high. So that is the one advantage. And then this SOFCs include a combined heat energy and then more power efficiency they are able to produce, and then they have a very long term stability, and then fuel flexibility is also possible. As I told you, we can make use of either hydrogen as a fuel and then methanol as a fuel. That flexibility we have, and then emissions are very low. If I use hydrogen as a fuel, it is not able to release any kind of gases, only water will be the product, and then these are available at very cheaper cost. So these are the advantages related to solid oxide fuel cell. These are also having very little disadvantages, as the high temperature range, that means operating temperature range, it is very high. So results will be taking a longer time, and then we have to face mechanical as well as chemical compatibility issues. So as I told you, it is having a lot of applications in spacecraft as a source of power generation. So that's all for today's class. In this session, we learnt about solid oxide fuel cell, that is SOFC, its construction, working, and cell reactions, and finally applications part. So that comes to an end for batteries chemistry, in which we have 4 in our syllabus. In the coming session or in the next session, I am going to start corrosion. Let us go with the introductory part of corrosion reaction. What is corrosion reaction? And then what are the reasons for corrosion reactions to take place? Few examples. Then we will go for mechanism, studying the mechanism of corrosion reaction. So that's all for today's class. Have a nice day.